This is an A-level pure question on partial fractions. So we have a algebraic fraction here equal to partial fractions on this side, and part A we need to find the values of the constants A, B and C. Now since this is an improper fraction, and we know that because the degree or the maximum power at the top is the same as the maximum power at the bottom, that's a degree of 2, it's improper. So if this power is the same or greater than the one at the power, it's improper. So we have a whole number part here, which is called the quotient. Now I can find this quotient by doing long division, or by setting out an equivalence relation here and solving it to find A. Now I think setting up the equivalence will be more straightforward than doing long division, so that's what I'm going to do. So let's set that up. So 1 plus 11x minus 6x squared all over x minus 3, 1 minus 2x is going to be equivalent to, now what we want is all of these terms to have the same denominator as the left hand side. So that means that A needs to get multiplied by x minus 3 and 1 minus 2x. The B over x minus 3 needs to get multiplied top and the bottom by 1 minus 2x. And the last fraction, the last partial fraction, the C over 1 minus 2x needs to get multiplied top and the bottom by x minus 3. Now all of these terms will have the same denominator, and that denominator will be x minus 3, 1 minus 2x. Now if the denominators are the same, it means that the numerators are the same. So 1 plus 11x minus 6x squared is equivalent to A x minus 3, 1 minus 2x, plus B 1 minus 2x, plus C x minus 3. Now I don't need to expand the brackets, I just need to choose values of x to make some of these terms disappear. Now if I make x equal to negative a half, this will become 0 and this will become 0, so all of this will disappear. So let's make x equal to a half. So then I'll have 1 plus 11 times a half minus 6 times a half squared is going to be equal to, so that's gone, C times by a half minus 3. So let's evaluate that and see what we get. So that gives 5 is equal to negative 5 over 2 C, and that will give C equal to negative 2. So let's just highlight that so it doesn't get lost amongst the rest of my working. Now I'm going to let x equal to 3, and when I let x equal to 3, that means that all of these terms in front of A will become 0, and this will become 0, allow me to work out B. So substituting in x equals 3, have 1 plus 11 times 3 minus 6 times 3 squared is equal to B, and that will be 1 minus 2 times 3. Again, we'll work out what that gives us, and that will give us minus 20 is equal to, let's say, negative 5b. That means that b is equal to 4. Now there isn't a value of x I can substitute in that will allow me to find a, so I need to equate coefficients, and I'm going to be careful about which coefficients I equate, because I want to make the working as easy as possible. Now when I expand the brackets, I'm going to get a coefficient of an x squared term here, but not from anything else. So that's what I'm going to do, just equate the coefficient of the x squared terms. So on the left hand side I will just get negative 6. Now the expanding brackets we should be able to do in our head. If I expand the brackets, this will give me minus 2x squared. It's the only x squared I'm going to have, and that gets times by a. So I'm going to have minus 2a x squared. So minus 2a will be in front of the x squared on this right hand side. So that's going to be straightforward enough to solve, and that will give me a needs to be equal to 3. So that will be my third value, and it's always good practice when you do these questions not just to write down the values of a, b and c, but to actually now state the final partial fraction. So therefore 1 plus 11x minus 6x squared all over x minus 3, 1 minus 2x can be written in this form. A, which we've got as 3, plus b, which is 4, so that'll be 4 over x minus 3. Then c is negative 2, so minus 2 over 1 minus 2x. So this is just good practice to leave your final answer in this form. So here we have f of x equal to the algebraic fraction in part A with this added condition that x is greater than 3. This is to stop us from getting 0 in the denominator down here. And also there are only going to be certain values of x that we can put into this denominator. In part B, what we need to do is to prove that f of x is a decreasing function. Now the first thing is that a decreasing function is one where the derivative f dash of x is always going to be less than 0, and we need to prove that f dash of 0 is greater than 0, less than 0 for x greater than 3. So we're going to find f dash of x not from this, but from what we did in part A. This is going to be easier to differentiate than this, and trying to use the quotient rule, it'll be a bit of a mess if we try and do that. So f dash of x, I guess the first thing I should do actually is write f of x in a form that's going to be a bit more straightforward to differentiate. So I've got 3 plus 4 times by x minus 3 to the power negative 1 minus 2 times by 1 minus 2x to the power negative 1. So f dash of x, well, the 3 will disappear. Then we can use the chain rule on these two terms that we have here. So we differentiate the outside. So we'll have minus 4 and then a power of minus 2, and this is x minus 3. The inside doesn't change. We multiply by the inside differentiate, well, we'll be multiplying by 1, so I can leave that as it is. And then same here, negative 2 times by negative 1 is going to be plus 2, and then the power will be negative 2, and then I've got 1 minus 2x, then we multiply by the inside differentiated, which is going to be negative 2. So let's just tidy this up a bit. So f dash of x is going to equal, now I'm going to write this as fractions now. So negative 4 over x minus 3 squared. And actually what I'll do is I'm going to put a negative at the front. So minus 4 over x minus 3 squared. That's going to be this term here. This one now, I'll also get negative 4 once I've multiplied it to a negative 2, so minus 4 over 1 minus 2x all squared. And I want to show that this is always going to be less than 0. Now let's have a look. The numerators, or the fractions themselves, are negative. Then the whole fractions will be negative if the denominator is positive. Now, what we'll say here, that since x minus 3, it doesn't matter what value of x you put in, greater than 3 or otherwise, since x minus 3 all squared is greater than 0, and 1 minus 2x all squared is greater than 0, what we'll have with f of x, or f dash of x, is negative 4 over a positive number minus 4 over another positive number. So then what we basically have is a negative minus a negative, which is going to be negative. And that means a negative, well, it's always less than 0. So I can now write down that since f dash of x is always less than 0. Now this is for all values of x, but I'll just put for x greater than 3 because that's the range we've been given. Therefore, f of x is a decreasing function. Decreasing function.